Hey, what's up, class? Just gonna spend a little bit of time today, probably around 20 minutes less, um, going over some homework problems that I saw people got wrong or I thought were worth going over. So I'm gonna present now. Hopefully, this doesn't take too long. All right, great. So we all see that the practice problems, great. All right. So number two, this is from homework lesson 3. Okay. So then, there we go. All right. So number 2, the data set represents the number of eggs produced by a small group of chickens each day for 10 days. They give the data set in ascending order, meaning it's going up 7, 8, 9. Select all values that could represent the typical number of eggs produced in a day. So the question you really need to ask yourself before you can answer this question is, what sort of calculation am I going to do to find the typical number of eggs? Like, what sort of vocabulary terms do we have for things that are typical values of a data set? Right, so hopefully you're thinking of mean, you're thinking of median. And so we've talked about a few times when mean is not appropriate, but median is. And that's when we have a skew. But in this case, we really don't have a skew. All the values are very, very close together. So I can use either my mean or my median. So if you remember how to do that, you go to stat on your calculator. If you're doing this by, you're using technology. All right. And you can see, I don't know if you'll be able to see this. I hope you, I don't, maybe it'll be backwards, but you go to stat and you press enter on edit. Oops, I press 0. And then you can just put your list into list 1 here. So as you can see, I've typed all my numbers in here. Then I'm going to go to stat, go over to calculate, press enter on one variable stat, press enter again. And I don't know if you can see it, so I'm just going to read it out. But it says the mean here, 7.6. If I scroll down to find the median, I get 7.5. So since we don't have skew, it's relatively symmetric. It's not perfectly symmetric, but it's pretty close. And obviously the mean and median are very close together. Both 7.5 and 7.6 are valid numbers that represent a typical number of eggs. So the mean or median would be okay there. All right, number 4 from the same homework. The histogram represents ages of 40 people at a store that sells children's clothes. Which interval contains the median? So it's important here that they're asking about the interval. If they ask for the exact median, we would not be able to answer that question. Much like a box plot, one of the things that box plots and histograms have in common, we don't know specific values. I mean, here I know the median, minimum, maximum, Q1, Q3, although sometimes these 3 values can be averages, right? If we have 2 numbers that are in the middle, we have to take the average. So sometimes if it's an odd set, right, if it's odd, we just take the number in the middle. But really, the only numbers we know for sure are the min and the max. In a histogram, we actually don't have any certainty what values, right? These could all be 1, these could all be 6. I don't know exactly what values are going to be in here. I do know, however, how many values are going to fall in that range. So for example, in this first range, I know I've got 10. So if I'm trying to narrow it down to the middle, when I cross off this bar, I want to cross off 10 and the other bars as well. So here I see I've got 4, 3, so that's up to 7. And then I get up to 5, that's 12 total. So between these 3, it's a total of 12. So I've gone 12 over on this right side and only 10 over on the left side. Let's try and go a little further. Now I see that there's 8 here. So I know between these 2, I've got 18. So I need 6 more over on the right to catch up. Got 3 in this one. So let me extend this here. We go from 12 to 15. Right, still a little bit lower than this bar. But what I can realize at this point is that if I've got 18 here and 15 here, and there are 6 total in this little column here, and here there are 6, I know that somewhere in this column is going to be that number that's in the middle, because I want it to be perfectly equal on both sides. So if I add 3, so if I extend this one on the right up 3, then it would have 18 total, and this would have 18 total. And somewhere in the 3 numbers remaining in this interval, that's where my median would be. So between 10 and 15, that's where that interval is. So we don't know the exact number that the median for age, or the mean for that matter, but we do know it's going to be somewhere between 10 and 15. That's in the middle of my data set. All right, that's all for lesson 3. All right, this was lesson 4, I believe. I don't think I took anything from lesson 5, right? Lesson 4. Okay, so just number 5 here. All right, let's pick a different color. Let's go with a nice indigo. All right, the box plot represents the distribution of the numbers of points scored by a cross-country team at 12 meets. If possible, find the mean. If not possible, explain why not. Well, to find the mean, right, we have to add all the numbers up and divide by the number of numbers. I don't know. I DK all the data points. So cannot. If this was a perfectly symmetrical distribution, which we honestly would not know from a box plot because we don't see the individual values, then we could say, oh, the median and the mean are the same. So if I know the median, I can find the mean. But I think it's very unlikely that there are 5 values here. Since there's 12 meets, right? I don't have 12 different dots here, so I can't calculate the mean. The median, we can find from a box plot. That's going to be this value right here, 34. Right, the median is always that middle line inside the box for a box plot. Did the cross-country team ever score 30 points in a meet? Exactly 30? I don't know. The only numbers I know have to be exact are the min and the max. Like we talked about earlier, these 3 numbers sometimes are exact numbers, sometimes are averages. It depends if the data set is even or odd. Right, if I have an odd data set, let's see, numbers all the way up to 7, right, then I know I'm going to have a number right here in the middle, perfectly in the middle, 4. I also know that now if I look at my first half of my numbers, I can find the number that's perfectly in the middle there too. Same up here. You can find a number perfectly in the middle, 6. Things get a little bit trickier when we get into even number data sets, which this is, right? It says 12 meets, so that's an even number. Here, my median for this data set is going to be in between 3 and 4, aka 3.5. So the median is not a perfect, is not an actual value in the data set. Same when I look at my lower and upper half. Well, actually, if I look at my lower half, I can find my median there. If I look at 1, 2, and 3, then I can see 2 is the median there. Or if I'm looking at 4, 5, and 6, I can see that 5 is the median here. Right. It gets a little bit trickier. There's actually a couple iterations of this. I could have an even number, but it'll be like, see how it's half of it is 3, half of it is 3, like both halves are odd numbers. I could do another example where I've got both halves are even numbers. Oops, 4, I forgot how to count. 1, 2, 3, 4, 5, 6, 7, 8. All right, here, my median is going to be between 4 and 5 or 4.5. That is always the case with an even number of numbers. Your median is always going to be an average of 2 numbers. But now, if I look at like the first half of numbers, so from here to here, right, between the median for this set, Q1, is going to be 2.5. So it's not a value in the set. Just like for this half, my median for Q3 is going to be 6.5, a number not in the set. So as you can see, it's not always so perfect. There are 3 different cases though. I guess there are 4 different cases, right? Because I could have, if I did 9 here, sorry, more than I intended to write about this. And it's not something that's super important, but I think it's interesting to think about. If I have 9 here, I've got a clear median of 5, right? That's right in the middle. And now for my Q1 and Q3, I'm getting 2.5 and I'm getting 7.5. So, it's the nicest data set we can think of is, I guess, an odd number where when you split it in half, both halves are also odd because then you get perfect numbers as your Q1 median and Q3. But you can see like there are a lot of different iterations. And that's not really so important. They're all just estimations of the first quartile, the middle, and the third. So it doesn't have to be a perfect number. But you can never trust any of these dashes to know that there had to have been a meet where they had 34 points, had to have been a meet where they had 33 points. Min and max, the only numbers I know have to be those. So did they ever score 30? Well, it's not the min or the max, so who knows? Maybe. All right, we just did a pretty intense job explaining the different cases you could have here, whether or not any of those lines actually represent something that actually happened. All right, lastly, on to lesson 10. I can finish this, so I'm not going to be able to finish that quickly. I was going to say, because in 5 minutes, they're going to start banging pots and pans outside the window, but I don't think you'll hear it. All right. Okay, lesson 1. Question 1, lesson 10. Select all distribution shapes for which it is most appropriate to use the mean. So when they're talking about using the mean, they're talking about something that's going to be symmetric. So symmetric right off the bat. Uniform, that's a symmetric distribution. Bimodal, symmetric usually. Bell-shaped, symmetric, pretty symmetric, right? The only thing that's not symmetric is a skewed distribution where we have something tail off to the right or to the left. Right? If it's tailed off to the right, the mean is going to increase. If it's tailed off into the left, the mean is going to decrease, right? These values that are the skew are pulling that mean away from the center. So everything besides a skewed distribution, it's okay to use the mean. All right, so when is it appropriate to use the median? Really, anytime it's okay to use the median. So, okay, for this, and this. Some people prefer to use the mean than the median because you could say the mean is more precise because it's taking all the numbers into account. Median just sort of takes the numbers in the middle into account. So if you think that outliers are important or they do represent typical cases, then maybe you do want to use the mean because you think it affects it. But the median will always be in the center, so it's always appropriate. All right, number 3. The number of writing instruments in some teachers' desks is displayed in a dot plot. Which is greater, the mean or the median? Explain your reasoning using the shape of the distribution. Well, we can see that this is a little tail here, right, over on this left side. We would call this skewed left. So if it's skewed left, that means the mean goes down, the median is not super affected. So that means my mean is going to be less than my median, and that's because it is skewed negatively. I wish I had like a pen I can draw here because that's very nasty handwriting, but it's the best I can do. All right, cool. So that was number 3. All right, that's totally up to skew. If it was uniform, what would be true about the mean and the median? Well, in a uniform distribution, or any symmetric distribution, I mean, it's going to be equal to the median. We get into skew, that's when they start to be a little bit different. We don't like to use the mean as much. Okay. Let's see, let's keep going. Number 4, did I do another one after this? All right, 4 and 7. All right. A student has these scores in their assignments. The teacher is considering dropping the lowest score. a lowest score. What effect does eliminating the lowest value, 0, from the data set have on the mean and the median? So I could plug this all into my calculator and compare the two different sets, one with 0 and one without. But we can figure this out for ourselves. So I know if you take out 0 from that data set, that's taking away part, like almost an outlier or an extreme. So my mean is going to go up. All right, if you take away the lowest score, now my average is calculated by mostly high values. It's going to stay up. My median, well, let's actually take a look at that, because median can sort of depend on what's going on. I want to cross out just my manual way of finding the median. I've got 4 on both sides now, so it's going to be between these two. That'll be 77.5. You could add those up, divide by 2, or just know what's in between them, right in the middle. So if I take off that 0, switch to a different color, I'm not going to include it, right? I'm not going to worry about it now. And let's see what happens. I have a feeling we're going to get just a 1-number median now, because there's not an even number, right? Now it's 80. So the median will also increase. I'm going to argue it's going to increase less than the mean. Actually, I'll just calculate these real quick, because just to sort of show you what we're talking about here. I'm going to my calculator, doing the same thing, going to stat, putting into list 1, 0, 40, 60, 70, 75, 80, 85, 95, 95, and 100. All right, so if I go to stat, calc, I'm getting a mean of 70. That's from the whole data set, including the 0. Now, if I go to stat and I take off that 0, my mean's gone up to 78. So that's a pretty big difference. That's up 8. This was up 2.5. So I was right in assuming the mean would increase more. All right, number 7 now. All right, the histogram represents the distribution of length in inches of 25 catfish caught in a lake. So out of these 4, what I want you to do is identify which of these can you actually answer, given the histogram. Can I find any of these values? All right, so hopefully you realize that it's actually impossible to, actually not impossible. Only one I can actually answer is D. And the reason why I can actually answer D is because 19 is not represented on the graph, right? I have no values for 19. So if there were any fish caught 19 inches long, there were none. I can tell that. Were there any fish caught 12 inches long? Well, I don't know. These could all be 15. These could all be 9. I don't know specifically if 12 is possible. Find the median. Again, when you're talking about intervals with 3 in between each one, it's going to be too general to find the median. I need specific values for the median. I could tell you which interval it falls into. We did that earlier. And if possible, find the mean. That is not possible. Specific values to find the mean. I got to add everything up and divide by the number of numbers. I know the number of catfish caught. I can add up all the frequencies, but I don't know how many more of each type. Okay, that's all for today. See you in our meeting tomorrow. Have a good day.